everyone.
Hi.
Can you hear me?
Yeah.
Hello, Carl.
Hello, Sarah. How are you? I'm just out of the shower. I'll turn my camera on in a bit.
Right, we're just waiting for Ray.
Ray is here. Oh, he's got my. It says Vicky Duncalf on your name, Ray. That is Ray there with the blue backdrop. Mars. Hi, Ray.
Apparently, I'm Vicky Duncalf because she gave me the same info to log on. So I'm Vicky number 2 tonight.
You lucky boy.
Pretty nice. I don't know how you've got yours laid out, but I've got you. I'm like sandwiched in between you two. Brilliant.
What a nice sandwich, a space sandwich. Oh God, that's. Can you change your name on it, Ray?
I don't know actually. I don't know how that works. I think it's because I've logged on with your thing.
Can I change your name?
If you click, I think it's the.
Oh yeah, I can.
The name actually. Oh no. Yeah, go on, do that. It's Ray Stott.
There you go.
Excellent.
Hey.
Thank you very much, Sarah.
That's right.
Well, this was a jolly nice excuse to do my hair and put some fun.
So
I've even got my snazzy leather trousers on.
We've got like a few people joining us live, but I'm going to make this into a YouTube video as well, so there'll be a lot more people watching it. I think also some people may have some reservations about giving all their personal details away to Zoom. I'm not sure how people feel about that, but I think that's effective.
Zoom knows everything.
Yeah.
Zoom now knows every last thing about us, doesn't it? Everything.
Okay, so are you ready to get started?
Sure, yeah.
Sure that I can.
That would be great.
Yeah, I should be able to see if anyone else tries to come into the room. So yes, let me have a look at my questions.
Let the grilling commence.
Huh?
Let the grilling commence.
Okay, so basically, what are the Starlink satellites, Vicky and Ray?
Oh, well, has anyone seen them? Hands up. Wow, they're amazing, aren't they? So Starlink have been completely bewitching the planet lately and causing countless UFO sightings. They go across this like a train of stars, sometimes close together, sometimes really far apart, sometimes low, sometimes high. And in fact, there's one going over at about 2 minutes in tonight and then one later. So Starlink is basically satellite internet for the whole planet. It's only very much in its infancy. The very first satellites are only just being launched, but when this network of thousands of satellites is complete, it's going to deliver high-speed broadband internet to locations where access. Can you see me okay? Say my connection's unstable. Is it okay?
You're kind of like freezing in one position. Well, that's all right.
Let me close some windows on my laptop. Let's have a look. Let me just close my Chrome. How's that?
Yep, that's right.
Yeah, okay. So basically it's high-speed broadband internet for where access has been unreliable, expensive, or completely unavailable. Currently, right now, I'm on a holiday park in North Wales, famous for its poor coverage. Well, this means you're going to be able to get internet in the Amazon, in a log cabin in Alaska. To be fair, it's going to be pretty amazing. So it really is making the news recently because trains of satellites in the sky are causing thousands of UFO sightings. I looked on Twitter to see what people have been saying about it, and one Twitter user has put, I saw these in the sky tonight, eerie, they look like satellites. Does anybody know what they are? So a website tracking UFO reports has also received reports of Aurora spacecraft sweeping across the sky in straight lines. That'll be Starlink. So Starlink satellites, they actually look like a flying barn door. That's a solar panel on them. They're kind of like a flat panel. They're about the size of a Tesla car. at Starlink and also SpaceX. He is also owner of the Tesla car company. And a couple of years ago, he sent a Tesla car into space with its own astronaut driver. So he's pretty goddamn ambitious. So I had a quick look to see what it says on his website, and he says, with performance that far surpasses that of traditional satellite internet and a global network by ground infrastructure limitations, Starlink will deliver high-speed broadband internet to locations where access has been unreliable, expensive, or completely unavailable. So that's a big mouthful. That's all one sentence. You definitely need a copywriter. I'm a copywriter, by the way. So SpaceX is amongst a number of private firms aiming to deliver the internet to underserved areas of the globe using microsatellites with online retail giant Amazon also planning its own network. So that is what it is. Yeah. So can you hear me okay?
Yeah, we can hear you okay. You're freezing up a little bit, but we can hear you okay.
That's a real shame. I'm sorry about that. This internet connection has been really good until tonight.
Oh, thank God for Starlink.
Thank God. Yeah. So should I continue then?
Well, we were talking, I was just having a little look today, and I was reading that one of the big issues with astronomers is this glare that's coming off them from their solar arrays. And I think we're due for the 9th launch. The next one's the 9th launch. And Elon Musk is saying that this launch, there's going to be dark foam on those solar arrays so they aren't producing the glare. But I was interested to know how many satellites are there currently orbiting our planet, and how much is Starlink going to contribute to that?
So I can chip in here if you can hear me okay.
Yeah.
So
wow.
we currently have
Ray, go for it.
We currently have about 2,000 active satellites in the sky. They're made up of different telecommunication satellites or weather satellites or scientific satellites. And it's about 50-50 between telecoms and scientific and weather. So it's about 700, 800 of split. A lot of satellites are defunct. They've run out of fuel. So they're still up there, but they're not operational. So active satellites is about 2,000. And you're quite right about the mitigation activities of SpaceX. I've also been doing some research for this evening's discussion. And they're doing a number of things, talking to the astronomy community to try and stop the problem, not only when they get up into their parking orbit, which is about 300 kilometers above our heads, but they then go into a higher orbit, which is about 550 kilometers. And the problem we're seeing with the deployment of the Starlink satellites is they're all in a train when they go up into this parking orbit. So 60 satellites get launched at a time on a Falcon 9 rocket, and they all follow in this nice stream of pearls, as people are seeing, and people are saying, what's that, as Vicky has explained. And they're about magnitude 1 to 2. So they're really bright because of that big solar array that Vicky explained. And that solar array is reflecting the sun at a big angle. So it's making us see the Starlink satellites really early on in the deployment. Now that's a problem for astronomy. Now later, when they go up to the 500 kilometer height, they go down. So actually you can't see them from the naked eye. That's a projection. But astronomers can still see them in the sort of deep space surveys and also with other instruments. So naked eye astronomy, they'll sort of disappear. They'll go to 6 magnitude. So you won't be able to see them as much. But the problem is the time that the satellites are in this parking orbit before they go up to this bigger orbit. So that explains why at the moment they're sort of startling everybody. And I've also read that SpaceX are trying to tilt that solar array. So instead of being at a high angle, it's a less of an angle, so it reflects less. They've put some mitigation on the spacecraft as well, like black paint and this other stuff that you've mentioned, which will stop the glare. And they're trying to work with a deployable sunshade as well to actually completely obscure the reflectivity down to Earth in the nadir direction. So these are some of the things they're working on while they launch up to the different operational orbits. But they're going to be adding a lot more satellites into space. So for example, we have 2,000 operational now, and it's going to go up to 20,000 with these constellations.
And I was also in my research today, I was noticing that Richard Branson's planning a similar constellation, OneWeb, and even Samsung are thinking about launching internet satellites as well. So surely that's going to be almost the same again of the amount of space debris or working satellites that we have once all of these satellites are deployed.
Yes and no. So the constellation of OneWeb, by the way, they're going through Chapter 11 bankruptcy in the US at the moment. So even though they have a constellation and they've just launched, I think it's about just over 400 satellites at the moment, and they've got operational, I think that's maybe SpaceX actually, 300 or so. Anyway, the constellation of OneWeb isn't at the same height, it's higher. So they're going up to 800 kilometers, even up to 1,200 kilometers. So they'll be definitely faint and not observable. So there's a big difference between the orbital heights of the different constellations. You're right in the sense that there's going to be more than one constellation up there. At the moment, there are 3 projected constellations. OneWeb, which is a bit iffy because of the Chapter 11, but they probably will get bought out, and the constellation will deploy a lot more satellites, not as many as Starlink initially. So they want to go up to about 800 to 1,200 satellites. And then the third project is called Project Kuiper. That's with Amazon and Jeff Bezos. So OneWeb is a consortium, and that involves Richard Branson with Virgin and his group.
Okay, brilliant. Have we lost Vicky? Is Vicky gone? Are you still there, Vicky? Oh.
You have to let her in, maybe.
Okay, I'll let her back in. Yes, you're there. Can you hear us, Vicky?
Hi.
Okay, so the next question about the Starlink satellites. When I was sort of sending you those questions earlier, I was thinking I haven't looked myself as to what they're actually doing in terms of how they're supplying the internet. I didn't really think about the fact that it's going to be another broadband supplier, and so there's obviously a massive profit making aspect to this. So how do you think that's going to play out in terms of Starlink being an internet provider?
Okay, do you want me to take that one, Vicky, or do you?
Yeah, go on, Ray. I mean, I've done some research on it today. It's going to be, they reckon it's going to cost about, I don't know whether you covered this while my internet was rebooting, the dish that you're going to get to receive it in your garden or outside your house is going to be about the size of a pizza box. He said it's going to be like a UFO shape. So it might actually look really cool and amazing and groundbreaking. Knowing Elon, it could be absolutely amazing. So this is going to go out in your garden, and it's going to have motors on it to track the satellites around the sky. So it's not actually going to come direct to your phone like some satellite internet satellite phone, should I say, like Iridium and a couple of others. This is going to be like, you're going to have like a digibox for it that then broadcasts to your property. So they're saying it's going to cost, they reckon, experts are anticipating it's going to be about $80 a month, which is what, 60, 70 quid. So actually it's quite steep. Yeah, it's not this amazing big free internet free for all that I was hoping it was going to be. It's a premium subscription.
Well, what I was reading earlier today as well is that they want to do it to fund their Mars One project.
Yeah.
That's the fundamental thing. He's trying to come up with a commercial venture to fund his primary objective, which is to get to Mars. And he's building the revolution of the rockets reusable with Falcon 9, Falcon Heavy, and Starship. So he's got 3 programs at the moment to sort of stage and get to Mars. And he's found out that building rockets to launch commercial satellites is profitable, but not profitable enough to fund his objective to get to Mars. So what's happening now is he's decided to invest in broadband from space, and he's taken the lead, of course, against OneWeb and Project Kuiper by being first to market. and he's dictating the market by being first to market. But his aim is to become profitable with that internet from space provision globally, to provide effectively global coverage for everyone, so you don't need to worry about having a connection, landline, etc. And he believes that will automatically finance and be profitable enough in order to fund his objective of getting a colony established on Mars.
When's the Mars One thing going to start happening?
It's not Mars One. Mars One is a project to go from the Netherlands. Mars One is a project to go one way to Mars.
Mm-hmm.
So that's a slightly different name. Maybe that's just a misnomer. His project is to get humans to Mars in the 2025 timeframe.
Yeah.
So he's building a series of starships, and those starships are going to link up and develop the capability to land automatically from the Earth into orbit and then to Mars. And then there's a resupply, and those starships will be full of cargo and eventually crew. So he's trying to land those systems on Mars first, establish a production plant of getting oxygen and water from the Martian surface, and then establishing a colony based on the premise of an ice mining town, because there's glacial ice on Mars, which has been discovered by the Mars Reconnaissance Orbiter, MRO, which is currently in orbit around Mars. And Elon Musk is his whole objective is to allow the species to go off planet, and he's doing that in a very short time frame. He wants the first landing on Mars with humans to be around 2025, which is very ambitious.
Well, he said that he reckons his profits from Starlink are going to be about $30 billion by 2025. So he can put that in the bank anyway. What was my other question? Oh yeah, so the sort of hardware systems that they feed back to on Earth, there are, what did I wrote it down here? So there's transceivers, and then there are like Earth stations. Do you know anything about those?
So
yeah, go ahead, Vicky.
Okay. Oh, okay. I was going to say it's the, from what I can work out, it's the pizza box. So that's going to be the domestic infrastructure anyway, isn't it, Ray? Correct.
So there's two ways that the satellite actually sends and receives signals. Remember that a satellite in space is basically a repeater, allows a signal to be sent up to it, and then it sends that signal back at slightly different frequency, or you get some service from this this triangulation off the satellite. And you can have a lot of satellite power in space. So these are the big geostationary satellites that do all that, or you have the technology on the ground. And what's happening now is we're having a revolution in this communications link, and the satellites have reasonably low power, so they're bouncing signals back, but providing a good service. And the terminals that Vicky has described, these UFO on a stick type terminals that she's talked about, that are about the size of a pizza box, are the domestic terminals. But the satellite also needs to be controlled. So therefore we have fixed ground stations, the bigger antennas that are on the ground in different locations around the world, that are used to actually do some control and commanding of the satellites from Earth. So that's what we call the ground segment and the ground control segment. But also the satellites are very clever. So they've put a lot of brains in the satellites to allow them to automatically avoid collisions with collision avoidance software in space. So effectively, you've got three things that will allow them to keep themselves in the right orbit and provide the services. The communication link between the control from the ground up to the satellite to keep them safe. The user control, which is the comms link between these pizza boxes and the satellites. But also the satellites themselves stop themselves bumping into each other with like collision avoidance software.
Brilliant, thank you. So the internet that they provide is going to be like competitive broadband for urban areas, right? But what about third world countries or places where they can't usually get internet? Is there any like freebies for people that would struggle to get internet otherwise?
We have to get someone on from Carphone Warehouse to answer that.
Well,
I don't know. What do you reckon, Ray?
that's a good question. So there is a constellation that's being built. Also, it's being deployed. It's called O3b. O3b is the other 3 billion, if you've ever heard what that acronym stands for. And that's a constellation that is bringing global internet to the basically population that can't afford to have internet. So it's giving all of the rural areas, it's giving the internet to latitudes that normally isn't provided around what we call the geostationary arc. So the geostationary arc is that very sweet spot of real estate that geostationary satellites sit in, where they appear fixed and provide services, telecommunication services above a certain region or above a country. When you have satellites that move around in different orbits, you're able to provide more global coverage to the other areas. Obviously, around the arc, they're sort of in the profitable areas like America or China, where people have money to pay for the services. But if you're providing services of telecommunications for the planet, you need to cover all the different areas of the planet and be in different orbital planes, going around the poles, etc., in different angles. And that's where constellations really come in, things like O3b. Your question if that's going to actually happen as a non-for-profit freebie from Starlink, I don't know. I think it would be very good of Elon Musk if he says he's going to provide, global coverage. Then it could be some offers to the people who can't afford that monthly subscription that Vicky talked about. But there are systems out there that are trying to cover the globe as well, and that one is called O3b, or the other 3 billion.
Okay, brilliant. Thank you. Another question. So what happens when they break down? I've seen that like a couple of them weren't working. Do they just like float around indefinitely?
Go on, Ray. This is absolutely your area of speciality.
Yeah, so they're at an orbit. It's all very relative. So 300 kilometers, the parking orbit where they first go now, and we see them in the train, is very, very, very close to the Earth. And their operational orbit's about 500 to 600 kilometers. The reason they're at this parking orbit, it is if they fail in those first few weeks of being checked out, Elon Musk or the automatic software can hit a button and say, okay, come back down again because it's not working. So they would then burn up in the atmosphere, and they would be taken out of the sky. If they get up to the operational orbit, as you go higher, it takes longer to come down. But there is a rule that all companies have to satisfy in low Earth orbit. These satellites are in what we call low Earth orbit. That's basically anything up to about 1,500 kilometers above our heads. And the rule is you can't keep an object in there without being able to deorbit in 25 years. So there is an international agreement that's enforced, and you get huge penalties to make sure that the companies are able to get them down if they want to within a 25-year period. And they can do that passively because at the lower orbit, there is still an atmosphere and the satellites will degrade naturally. That's why it's called a parking orbit. But when they're in operational orbit, they could last a bit longer than 25 years, but they have small thrusters on board that will deorbit them closer to the ground, electric thrusters, and then towards the end of their life, they can be shot down to Earth and then deorbit and burn up. So Elon Musk, before he proposed this constellation, came up with a way of removing all of the satellites if he decides to.
Okay, can they be knocked out by meteorites or other things like that?
Yes, they can. Anything in space can have something hit it, and that would cause a problem. Potentially spin it around, cause it a problem to not be in control, or it could knock out the electronics. And if that happened, then you wouldn't have active control. So say it took out the electronics that wanted to send it back down, then you'd have to wait 25 years, worst case, if it was in the higher orbit, for it to come back.
Okay, great. What's the life expectancy of those satellites? Are they in an orbit? Because what I was reading earlier was saying that they're in an area where there's a lot of atmospheric drag, so their lifetime's a bit shorter than normal.
That's right. Again, it's all related to the orbit. So the higher up you go in what we still call low Earth orbit, the satellites have a certain lifetime because the molecules of the air are still there, even though there's not many molecules actually there. And they actually cause the drag, as you mentioned, on the satellites. And the satellites, depending on how big they are, the size, if they are a big surface area. So for example, a ball-shaped satellite wouldn't be as much affected as one which is got like a big solar sail or something. So depending on that surface area, the atmosphere hits it, and then it lowers the altitude of the satellite naturally. And over time, that will drag the satellites not only down, but also out of position. That's why they have automatic control sensors on board and thrusters and reaction wheels or software to make sure they can keep in the right position and always put the antennas looking at the Earth or not pointing away into deep space. So yes, depending on the height, then it dictates whether they will come down. In fact, some small CubeSats are actually deploying like a sunshade or an umbrella, and that umbrella is not to protect from rain, it's actually to make a drag based on the area. And because they deploy an umbrella device at the end of their life, it accelerates them down because it's a bigger surface area. It catches those molecules of oxygen at the top of our atmosphere, and then that forces the satellite to burn up. And that's the way we can keep the lifetime of the satellites. They're generally 5 to 7 years life in that sort of orbit. And that's why the constellation will get replenished by regular launches of more satellites. So they won't just stay up there. They have to keep being replenished because they are in low Earth orbit.
I was reading something about the different orbital shells. And are the Starlink satellites just in one orbital shell, or are they going to pass into other orbits?
Okay, so we talk about covering the whole of the Earth. The shells are called planes. Okay, so it's not shells around the satellites, it's different planes. So if you go around the equator, it's called 90 degrees azimuth. If you're at the 12 o'clock position around the poles, it's 0 degrees azimuth. What with all the Starlink satellites, they're in planes going around the poles, then at say 20 degrees, 30 degrees, 40 degrees, etc., right up to 90. So these constellations of satellites are in different orbital planes, both that way and around the top and around there. And that's the way, because they're moving, these move across the sky, they're able to have 3 satellites in any one portion of the sky over any one portion of the Earth at any time, and you can triangulate and communicate with them. And the antenna that Vicky was describing, that's a pizza box antenna, can take a signal, track a signal from these 3 satellites and give you a connection. And that's how it works, because they're moving.
Okay, great. When do they start spreading out? So they've been in trains for the most part. When are they going to start forming this like net-like shape around us?
About 2 to 3 months after they've been checked out in orbit. So they get launched in batches of 60. We just had a launch this week, and there's more planned for next month. So they're launching very regularly, every sort of 2 to 3 weeks. That's quite amazing, and recovering the rocket. But the plan is to get them up in those strings, and then they'll check them out automatically and also from the ground. Some will fail. They expect a lot of failures. And then the ones that fail will drop down, and then the ones that work will then automatically, with their onboard thrusters, go up to the operational orbit of about 550 kilometers. And then they spread out. They spread out, so they don't stay in the same. I think they go into these different orbital planes, so they go evenly around the globe, and they start to dissipate into these different operational positions to get the coverage.
Okay. I was talking to you earlier, Vicky, about you've got a lot of astronomer friends, and you've been saying that there's quite a lot of concerns amongst the astronomy communities about visibility now in the night sky. Oops, can't hear you.
Vicky, you need to unmute.
Just unmute. There you go.
Sorry about that. Yeah, hopefully my internet won't go off again. So yeah, I'm an astronomer. This is my beautiful telescope behind me. A lot of astronomers take long exposure photographs of the sky, and the Starlink kind of go across almost like claw marks is the best way to describe it. This does have a lot of implications as well, not just for amateur astronomers, but for professional large telescopes who are really worrying about the fact that very shortly, with these thousands and thousands of satellites up, that they're deep sky observations, which may involve looking for things like distant supernova explosions or even asteroids coming towards us, could be marred, and calculations can be messed up from them. Yeah, some of my astronomer friends call them sky vermin. And I know that's quite strong, but yeah, it's a really, really controversial. None of us really know how it's going to pan out, but to be honest, it's not looking great.
But some astronomers are obviously working with Elon Musk to try to minimize the brightness of the Starlink satellites. And Elon Musk is claiming that once this dark foam is on all of them, it's going to be invisible to astronomers. But I did see that it got in the way of the ISS not so long ago. There was like a bit of a interruption.
Oh, okay, right. So
I can pick that one
Elon,
up if you want, Vicky.
Yeah, I'll just say that I was reading that Elon is great because he's probably going to really help the astronomers, but that doesn't stop a less scrupulous operator or country sending up bright reflective ones. You know,
I'm sure Richard Branson will be really glary and brash, won't they?
Yeah.
So I've also heard some stories about this. So and read on what's going on. So Elon Musk is working with the American Astronomical Society, the AAS, and they have a big telescope in Chile. And he's trying to understand how he can mitigate the effect of their deep survey observations, because they have very sensitive instruments, obviously, in the telescope on the ground. And he's doing it in two phases. From what I understand, optically, so there's the optical part of astronomy. You've got the radio astronomy, and you've got things like infrared astronomy. So if we talk about optical astronomy, the interesting thing is, yeah, we've got these flashes and it's affecting us at low altitude, as I've explained, and he thinks that he can mitigate that, and in general the problem should go away. The problem becomes they're still there at this 500-kilometer altitude, and they're still observable by the sort of bigger optical telescopes. And he's working with the different organizations to try and make sure that they minimize the impact. And he thinks that the percentage impact on those type of deep space surveys is about 3%. That's the actual figure. Now, I've also read some interesting things about international laws regarding different parts of astronomy. There are big laws and conventions in the radio astronomy field. Everybody tries to keep the signals from not interfering with each other, from radio and terrestrial radio and things like the big Jodrell Bank telescope here in Cheshire. But for optical interference for telescopes, there's no international law. There's no UN body that actually regulates optical reflection from satellites. So actually there's no laws governing this. And there is a law governing the removal of satellite constellations, this 25-year law. And also there are international bodies like the International Telecommunications Union, or ITU, that sits in Vienna in Austria. And they authorize these satellites to go up into space. If they don't give their okay, then they're not allowed to fly. So I think what we're seeing is the beginnings of a regulatory scheme happening for optical satellites because of this concern from the astronomer community.
Okay. So I was reading somewhere that there's going to be a 12,000 of the Starlink satellites, and then other places it says it's going to end up being more than that. So yes. What effect do you think that's going to have really on the atmosphere with these many thousands of satellites? Like, it's a massive increase from what we've had previously. What
Vicky,
kind of
do you want to say anything?
Go on, Ray.
So we've got
Go
these
on, Ray.
2,000
I guess it is,
operational satellites, Sarah.
Yeah.
And we're going to massively go up to these 12 or 20,000 or even in higher, very, very short time over the next 2 to 3 years. I don't think this will be a problem, personally. Everybody thinks that it's a lot of numbers. What you've got to understand is that the space in low Earth orbit and medium Earth orbit and high and geostationary orbit is very big. So when we talk about these satellites, which are, you know, table-sized satellites with this solar array makes them about the size of a car, as Vicky was saying, when it's deployed. Yes, they are a certain size, but actually there's a lot of space around them. And you probably see these simulations of the debris or satellites in space that are concerning. They're true in a way because you actually have a huge database, whether you rely on the Western world's view of how many things are up there or the Russian view. In fact, it's very interesting to compare. Nobody agrees on how many objects there are in space. It's all about data. So if you look at a data set from say America and compare it with the data set from Russia, you'll see two different things about what's up there. Obviously, it's a mixture of the two. But you've got to remember that space is big, and collisions will potentially occur, and you have, as you said, maybe an issue with the International Space Station, but we're still able to mitigate that. What we need is a space traffic control system, and what's being developed is the equivalent of an air traffic control system in space, and also the companies and organizations that operate in space need to be good. They need to have good policies, and they need to adhere to international rules and regulations. And as long as they do, then we will minimize the impact. But putting this number of satellites in space, in my opinion, is not a problem. It's about how you control them.
So who does Elon Musk have to go to for permission? You said about this, this organization, this international body in Vienna, but is that the only place he needs to go to? Because it is like a global issue. So there seems to be like a lot of permission given by agencies in the US as well.
That's right. You have the FCC, the Federal Communications Commission, the equivalent of the one in Europe, and the FCC and the ITU, the International Telecommunications Union, are currently the only bodies that regulate for this area. They say yes or no. Obviously, the FCC is American, but there is no world body. There is no UN equivalent for the equivalent of radio astronomy. And but also remember, there is no agreement to minimize the pollution on the high seas. So we're actually in a similar situation to plastic on the high seas. We don't have a body that looks after the high seas for pollution of the high seas. So this is not new for the human population. This is something that we're not very good at. And what we have to do, I think, is get a body that represents optical astronomy, just like radio astronomy, just like infrared astronomy, and regulate and control how we go in to explore the solar system.
Yeah, this brings me on to the next question. Do governments, corporations, the military have any kickbacks to get from this Starlink satellite program?
So yes and no. So there is a commercial interest to get Starlink to get to Mars. That's the primary driver for that. I don't think there are kickbacks per se, unless you maybe take a different view for the military or civil systems being deployed. Everybody is in open competition to exploit the resources of space, and any country can, I would say, in a very democratic way, gain access to space, either in regulated space, that's the different arcs of space for telecommunications or science or astronomy, but also there is a way to mitigate these issues, because there are a few treaties around, but these treaties need to be updated for space law. So there is the United Nations Peaceful Uses for Space legislation. There is also the Moon Treaty, and all of these are now being tested because the world is now on the brink of exploiting space resources, and unfortunately, space law is behind the times and it needs to be updated. So yes and no is the answer to your question.
Is it possible that any of the Starlink satellites could be used to collect some form of data that could be used for military or governmental purposes? Because I did see something about Starlink having that as a potential income stream, that some of the information could be used by militaries or governments.
Anything you put into space or the sky or the area above us can have a civil or a military use. So again, the answer is yes or no. If we're not told about that, or there are some secret stuff going on, then potentially yes. But that means that anybody in the world can do that as well. So it's not Starlink that's limited to deploy civil or military systems. Any country in the world can do that if they have access to space.
Do you think that the things like Starlink were heading towards this kind of technocracy or a digital dictatorship in some ways? Like people like Elon Musk, are they going to be the people that are in charge of the planet?
I'll pass this one over to Vicky.
Oh God, I mean, that's such a difficult question, isn't it? I think that this one's definitely for you, Ray, with your expansive space mind. Personally, I don't think so.
No, I think there is an element of, if you control the area, you control the marketplace. It's like any commercial thing as well. But we are explorers, and as explorers, once we explore, we want to exploit. And the human psyche means that we want to go and find what's over the hill, and we are natural explorers. But that comes with a caveat. We pollute as we explore. We have a responsibility as we explore, and then things are developed in a commercial area to take advantage and to generate where we are in society at the moment. So space is no different to the high seas, to land and things in the past. The critical thing is that first to market applies anything as well. There will be an element of a Wild West, just like there's been an element of a Wild West in the past. But I think now, especially looking at how things are affected on the planet and the fact that we are, as a species, looking to conserve the planet, I think this is much more a rational debate. So that actually puts some brakes on what I would call the uncontrolled cowboy aspect of development and uncontrolled development. But there will always be tension between wanting to explore, wanting to conserve, and wanting to develop as a species. And somebody asked me this question about, you know, everything's unnatural and natural. We are naturally on this planet, unless you believe otherwise. We naturally produce pollution, and we naturally build buildings. So even somebody says the buildings of concrete and the things that we have around us are artificial or unnatural, I have an opinion that they are a natural part of this planet's progression. We have a responsibility, and space is no different for that. It has a technology that's with it. We will pollute, we will control that. We need to make sure we manage that, but it's actually natural. Us developing on the planet, it's natural for us to go into space, and we will naturally have corresponding pollution that will occur because, unfortunately, or fortunately, you may see that on two sides. That's a consequence of our natural growth into the space sector.
Fantastic. Well, I'm going to open this up now so that anyone that wants to ask any questions is free to do so. So does any of you lot have any other questions?
I had one.
Yeah.
What was it? It'll come to me in a moment. Just need to remember it.
Any questions, Steve?
I asked him one about it.
I'm not sure if it's been covered already, but like, what regulations are there in place about people putting satellites up, you know, in the atmosphere?
It's a very good question. Is that Alex, is it?
It is. Hello.
Hi, Alex. How are you doing? Yeah, so there are very strict regulations. You can't launch anything without having the licenses These licenses are very, very expensive. So actually the UK is deregularizing the cost and trying to make the ability to launch into space easier, because the licenses cost so much money. We're trying to have launches from the UK in Cornwall with a spaceport with Virgin Orbit, and also in Sutherland in Scotland. So if a country launches something into space, they're responsible for it. So for example, the OneWeb satellites, which are currently in orbit, the second constellation that Sarah was mentioning about, they're not as advanced with the Starlink satellites. The actual responsibility for that rests with the UK government. So if there's any damage, then, or if there's, say that hit the International Space Station or there's some debris, the costs are borne by the UK government.
Okay. Thank you.
I've got one. So is Musk actually doing anything about, instead of using Starlink to send himself to Mars, what is he doing anything about space junk research? Do you think that would be a more pressing issue? And then you can go to Mars. Once you've solved space junk, then you can go to Mars.
Space junk is an issue, but I don't think he's focused on it. There are a lot of companies, small, medium, and large, that are actually coming up with solutions to remove space junk, Vicky. But I don't think Elon Musk is focused on that. He's going to Mars. That's his focus. He's not looking. At the moment, there's no revenue to collect the space junk, even though there's lots of useful stuff. There's no revenue stream now, apart from the reorbiting of space junk and active, which they just demonstrated actually by having a satellite lock onto another satellite and give it an extra life. But space junk, if it's not useful anymore, is at the moment not a profitable operation. So therefore, I don't think Elon Musk is going for that.
Okay. Excellent.
Well, what other uses apart from the internet? Because I've heard about cars, smart homes. What other uses?
So the satellites, will they kind of speed up the driverless cars situation and make all of our homes smart homes?
Very good question. So we need a telecommunications network that allows the technology in driverless cars, for example, to happen real time. So we can also have the power of being able to use the different sensors in the world of 5G. So that's why for 5G on the ground, for example, the need to have a mast every like 20-30 meters around an urban area is why there's a lot of masts being built and for our cities. Elon Musk's Starlink is like a 5G in space, so it will accelerate the capability to do this across the planet and not just in urban areas.
Harder to burn down a satellite as well, isn't it?
That's a very contentious issue. That I don't know how that's even happened. That's bizarre.
I did read something about how the plans for the satellites are fairly open. You can have a look at them, but there's enforced confidentiality on the optical inter-satellite links. Do you know anything about why that would be the case?
Yeah, so a lot of companies are trying to control satellites with lasers or inter-optical satellite links. So if you have a satellite here and a satellite here in space, and you can send a laser between the two, you can do two things. You can see where those two satellites are, but you can also send information across the laser beam. So the reason that everybody is having a commercially sensitive bit about that is it's the new technology. So with this, you'll be able to more data can be used to send around the network, because you don't need these big ground stations to downlink all the data. Immediately you can share the data stream across your satellites and then downlink with one of the big antennas on the ground at the appropriate time that the satellite can go around. So you can basically increase the efficiency of managing data, and you can massively ramp up the data capacity of your network. So it's very commercially sensitive, and the technology is being proven now, because in order to communicate, the satellites have to lock on to each other, but they also have to be quite stable. So you can't have a satellite that's tumbling around and not being controlled. So the control of the satellites has to be really, really good to be able to lock on to the other satellites, to have what we call inter-satellite links. But it's a very, very interesting area, and it will dramatically change how much data we can handle from these constellations.
Okay, fantastic. Has anyone else got any questions? Carl, I just muted you because you were making household noises. Are you there, Carl? No, I think he might be in the background. Well, thank you so much, Ray and Vicky, for joining us. It was amazing, so informative. Do either of you have anything else that you'd like to add about Starlink or Elon Musk? Are you Elon Musk fans?
I think after learning more about Starlink, I've got to say, yeah, I probably am now. Apart from the astronomy thing, very mixed feelings about that. If I went on Facebook now and said that Starlink was amazing, I would lose some of my best friends because they're so upset, deeply upset. So let's see what happens.
I think I'm biased towards Elon Musk, because I think he's a pioneer, and you've got to give him some credit for that. But equally, he has a responsibility like any pioneer. If you look at the analogy for streetlights, most people in urban cities can't see the sky anyway, because streetlight pollution is stopping that view. The fact that we have a few more satellites buzzing around, unfortunately, they can't see them anymore because they've lost their view anyway. So it's a double-edged sword. I think he has a huge responsibility because he's first to market. And also, this is brand new. We didn't know that the satellites would be so reflective, but he's trying his best to mitigate that. Progress always has its handicaps, and I think we're learning as we see, and he's trying to be the responsible person. He's in dialogue with the astronomical community. I think the longer term thing is clever software can start to mitigate these passes in low Earth orbit. So you can effectively negate the issue with clever software for deep sky surveys. But the problem is, optically, it's going to spoil some of your views when they're in this low Earth orbit, parking orbit. As they go up into their operational orbit, the effect on the amateur astronomy is going to be reasonably small, I think. It's just the time in the parking orbit. But it's something new. We have to be aware of it. And I think the main impact will be on the deep sky surveys that are done by the big telescopes, these ones in Chile that I mentioned, or very, very sensitive sensors on satellite on telescopes around the world, and they're going to lose a small percentage of their viewing capability. But that's one of the handicaps of moving ahead with technology. There will always be some negatives, I think. So I'm leaning towards responsible exploration, I think, is my catchphrase.
And also, with him being first to market, I suppose, if some regulation was introduced for optical astronomy now, it would prevent too many competitors potentially getting in there as well, would it?
Yeah, that's true. And it's kind of interesting that there is no regulation for optical reflectivity off satellites. And I think every astronomer would say, as soon as we had Sputnik in 1957, they were starting to complain. But satellites have revolutionized astronomy because we can put those satellites into space. So everything has a give and take. So we've advanced. If we didn't have satellites, we wouldn't have Hubble. We wouldn't have these planetary spacecraft that are doing revolution. So there are disadvantages and advantages in having telescopes on the Earth and in space. And I think we've got to have the balance of space-based and Earth-based telescopes. And there will be advantages and disadvantages in both environments.
And it would be fun to go to other planets as well, I think. And I love Star Trek. Elon Musk loves Star Trek. I bet you love Star Trek, right? I bet you like Star Trek, Vicky, right?
We do.
Reckon we should go to the planet?
Great, isn't it? Yeah.
I wouldn't personally volunteer for Mars myself, but I like the idea of it.
Well, currently, a holiday lodge, we're isolating on a caravan park, and the lodge is like a double-sized caravan. For 5 years, we lived in just a normal, standard-sized holiday caravan together. And on a rainy day, I used to get cabin fever in about 10 minutes. So I know that going to Mars will be very bad news for me. If you could spend 14 months living in a caravan without going outside, feel free to go to Mars.
Perhaps use that caravan park as the Mars training ground.
Oh my God, yeah, I tell you what, you'd be welcome. Yeah, there's plenty of empty.
That sounds like a
choose from.
Mars project to me.
I think we're all in a Mars training ground with the lockdown at the moment. So
Yeah.
I think we're all experiencing what it's like to be in a Mars isolation, and also the fact that you are limited with resources, and also you need to talk like this to keep in touch. Don't forget that if you do that with the Earth from Mars, everything's delayed by a certain time frame, so it's not real-time communications. So.
Have you, I kind of was really fascinated by the Mars One project when it first started, and really enjoyed watching those videos of the people that were prepared to go to Mars, and just wondering who would actually do it. Because I think it's a really incredible thing to volunteer for. It's unbelievable. So Elon Musk really thinks he's going to start going there by 2025.
Yes.
This is a whole other episode of Explorers Club we should do.
Yeah, I think he will achieve it, because the Starship vehicle he's developing in parallel multiple test vehicles to get these things flying, just like he did with Falcon 9. And this is a huge deal. This Starship will revolutionize our way of moving around the planet, because it can go up into space and drop down again very quickly. You can get to Australia, for example, in 20 minutes with this device. So you just go up, drop down again. But to go to another planet with a vehicle that is reusable, but also have the infrastructure on Mars to be able to fly back with, using the resources on Mars, he's really pushing the curve. And I give him every credit. He's going to fail on a few things, and he's planned to fail. So he's planned, his latest few prototypes have all exploded in Boca Chica, the Texas launch site, where he's testing these starships, and he's going to do some bunny hops in the short future with the big vehicle, even as much as the next few months. But remember, he's going to the moon first. So he's sending one of these huge starships with a Japanese artist and some friends around the moon first. He's already got that paid for. He's already got that completely financed by some Japanese artist billionaires. So he's clever at networking. Huh?
That's amazing. Can we do another Explorers Club about Mars and the off-planet adventures? Because that would be amazing as well.
Yeah, we'd love to help out. Space Specialists would love to help out.
Brilliant. Okay, awesome. Well, thank you so much, Vicky, and thank you so much, Ray, and thanks everyone for joining. And this has all been recorded, so I'll put this up onto YouTube and share it with you all afterwards. But thank you so much. I really appreciate you taking the time to do this. It was absolutely fascinating. Thank you.
Great.
Bye. Nice to see you all.
Keep learning, everybody. Thank you very much.
Thank you.
Bye.
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 Bye.